Hello friends, our today's point is geometry of friends. We have already seen this into two-dimensional space. First, we will differentiate what is difference of linear equation between 2D and 3D. Just draw a line. Okay, here we will write about 2D. Here we will write about 3D. Friends, geometry algebra. I mean, linear algebra is all about the linear equations. Okay, so in two-dimensional space, each linear equation represents a line. Okay, and here each linear equation represents a plane. Okay, in two-dimensional space, we will have two equations versus two unknowns. Okay, in three-dimensional space we will have three equations versus three unknown. Okay, UNK I have written as short form means unknown. Okay, these are the main differences. Also friends, if in two-dimensional space two lines intersect each other, and at the intersection point we have a solution. Like if this one is line, this one is line, the intersection of these two lines is nothing but a point. Okay, and it is nothing but a solution of our linear equation. But friends, into three-dimensional space we will have a plane. Okay, we will have a plane, and intersection of these two plane, we will have actually three planes. If I will draw a third plane, it will make figure complicated. Okay, intersection point of these three planes is nothing but also a point. Okay, but intersection of only two planes, first two planes will intersect, is nothing but a line. Okay, if third plane intersect this line, then we will have a point, and which is nothing but a solution of our equations. We will see this. Don't get confused, we will see this thing in detail in coming point. Okay, we will take a new window. Friends, we have already seen that don't get confused. First, don't get confused with this figure. I will explain it. Just listen what I am saying. We have already seen geometry of equations in two-dimensional space. There, we have seen that we can represent equations by two ways. First one is by row, okay, and second one is by column picture. First, we will see a row picture. Just see here, we have these three equations. Okay, each equations represent nothing but a plane. Okay, I have written solution of this equation, which is 1 1 2. Okay, now come to this picture. This represents a row picture, okay, of the equations. Okay, here if you see, this one plane is represented, this equation represents plane number 1, this second equation represents this plane number 2. Okay, intersection of these two planes is nothing but a line. Okay, this, and third equation also represents plane, but I have not drawn. I will draw it. It makes a figure very complicated to understand. Nothing but solution of equation 1 1 2. That much simple is this. This is a row picture. Okay, so what does row picture represents? It represents intersection of planes. That much simple. I think this is clear. Just draw planes on three-dimensional space on three-dimensional graph. Okay, like this, and and find out the intersection. That much simple is this. After that, we'll discuss this thing somewhat more. Okay, with example. Just a second. We'll take a new window. Okay, okay, row picture. Example. Suppose I will give example about four-dimensional space in which we are living. Okay. We are living. Uh, suppose x, y, z, and t. T is nothing but a time. Okay, this is these are the coordinates of four dimension. If take this 4D, will cut t equal to 0. If t equal to 0, plane. Okay, t equal to 0 is nothing but a plane in dimensional space. If this plane cuts 4D space, then resulting picture is 3D space, which represented by xyz coordinates, which is a three-dimensional space, length, width, height. Okay, but just a second. But furthermore, this one is furthermore, if we'll intersect by plane z equal to 0, this plane cuts 3D space, then what will be the result? Then picture is 2D space, means at each by plane dimension is get reduced by 1. Okay, if we will intersect furthermore by y equal to 0, then resulting is a 1D space, and if we intersect by x equal to 0, finally we get 0 space, which is nothing but a point. Okay, here it is a line, means at each intersection it gets reduced by 1. Okay, the general principle, at each intersection the dimension of the space is get reduced by 1. Okay, if dimension is n, then the next intersection will reduce it to n minus 1. Okay, after that n minus 2, after that n minus 3, likewise. Don't think much about this figure, I will explain it. Just look at here. These are three equations. Okay, in and we know each equation represents a. Okay, I have solution for it. Okay, in row picture we have seen that these three equations represent plane, and UVW is nothing but intersection of these planes. Okay, which is 112 is the solution. Now we are in the column picture, and column picture, consider Means principle behind the column picture is equations into the column. First we will represent equations into the column. Okay, we'll convert these equations into column form. Don't think much about this figure, I will explain it. Okay, column form. We have variable u. Okay, just a second. Two 4 minus 2 plus v, coefficients of v 167, oh sorry, minus 6, 1 minus 6 7 plus w, coefficients of w 107, 107. Okay, equal to finally a right hand side 5 minus 2 9. Okay friends, now we have UVW, which is nothing but a solution of our equation. Okay, but before that, this form tell us that the final B, okay, this B is nothing but combination of these three column picture. Okay, this final B is nothing but combination of these three column picture or vector. If you believe, just see here, if I will place 1 1 2 in place of UW, see what will happen. 2 4 minus 2, okay, plus 1 minus 6 7 plus 2 times 107. Add 2 plus 1 plus 2 into 1 2 means equal to 5. Okay, 4 minus 6 0 means minus 2. Just a second, bad handwriting. Okay, you calculate it, the answer will be this. Okay, cross check it. It means we can represent in a column picture column as a combination. Okay, find out the UVW. It what is the combination of the column gives us B. Okay, this is nothing but our solution. Okay, friends, now come. This is a vector graph. I have combined this and this two column, okay, here, and this single column here. Okay, after adding this we will get the final result vector. Okay, 5 minus 2 9. Here I will write down 5 minus 2 9. I have added these two. 2 plus 1 is equal to 3. Then 4 minus 6 minus 2, and after that 5. Okay, 2 0. Just a second. Here we have 2. Okay. 204. I have multiplied this. This figure also represents the same thing what we had done here. Okay. The combination of these two, addition of these two is nothing but our final vector 5 to 9. Okay. Our in column picture our aim is the combination of the column that will give us a B. Okay, that much simple is this. I have combined these first two vectors into the here, and last one vector here. Okay, you can draw it separately on the three-dimensional graph and clear for you. See singular cases which may have infinite, which we can have infinite number of combination, okay, to find out the B, or which will have no any combination. Okay, these cases also we will see in future. Okay,